Good morning, everyone. My name is Dr. Alan Barnard. I'm CEO of Goldratt Research Labs. It's a great honor to present this morning at the TOC ICO 27 conference here in Berlin, Germany. My co-presenter this morning is Manohar Mandira from Microsoft, and we have the honor of presenting to you a case study, a TOC-based supply chain solution implementation that has been done at Microsoft over the last 18 months. I'll hand over to Manohar to take you through the agenda for this presentation.
Thank you, Alan. I am humbled and honored to be presenting at this conference. I've sat in these chairs before, learning a lot, absorbing what is TOC about, and especially all the insights that are shared from other implementations. Hopefully what we have done here will also add some insights into the growing knowledge of TOC. First, we'll go about introducing what Microsoft has to do and where we have implemented our One Devices in Supply Chain initiative, the results that we obtained, and then we'll go through this solution design and check for and go through the process of how we implemented it. Alan will then give a simulation of the simulation for the model, and then finally we'll go about where we are with the implementation and where we are going forward. So first, let's get the white elephant out of the room. Let's talk about why does Microsoft, which is known in the world for Windows, Office, Azure, Bing, why does it need a supply chain? What does software have to do with the supply chain? So Microsoft actually has got a whole lot of work and space in the hardware business. And what we'll do is talk about the complete set of activities that go on at Microsoft with regards to the hardware. And it might be a surprise to many of you that Microsoft has been in the hardware business since the 80s. And believe it or not, it used to produce some enhancement cards, performance enhancers for the Apple. In the 80s, there was the Apple soft card, then the Mac enhancer, and then we got into the PC hardware business where keyboards, mice, and pieces. The big leap into major hardware was with the Xbox in 2001, and then the subsequent very successful product of Xbox 360 in 2005. We also had some more hardware products like the Zune, which was a precursor for iPod, the Surface 1.0, which was sold in the casinos. It was used as a table on which you can drink coffee and play games, and Keynote in 2010, which actually is in the Guinness Book of World Records as the fastest selling electronic gadget. I'd like you to pay some special attention to the years that I've mentioned here, because that will relate to the storyline as we go forward about why we had to do what we had to do for the TOC. Today, we have a whole line of Surface products here from multiple form factors, Surface Pro, Book, and the Studio. We have the Surface Laptop that was recently launched, and the Surface Hub, which is a 55-inch, 84-inch screen that you mostly sold in the organizations and in conference rooms. Apart from our Xbox family, the augmented reality products like HoloLens, and in the field of mass customization, custom controllers, where you can go online and order your unique combination of what the controller should look like for yourself or for your kids. So Microsoft supply chain, let's just look at the numbers. We have the whole process from new product introduction to sourcing, planning, manufacturing, checking for quality, compliance, and finally the global supply chain, ensuring that the product reaches to all corners of the world, and the care, which is the support and how we service our devices. We have over 290 million units shipped every year with 31,000 active SKUs, about $11 billion in the amount of annual spend on our inventories, and more than 600 suppliers. 13 manufacturing locations, 52 DCs where we distribute our products from, whether it is for care or for the forward supply chain. And One thing of note is the 191 countries we serve. Barring the few countries where there would be embargoes, we serve pretty much every country on the planet. And we have over 30,000 outlets through which we serve them, which is including our carriers, retailers, and the MS stores. So our changing landscape, as you would have noticed from the products that we are launching, we have earlier, before 2015, as we were going into the Surface business, we had one major event every year, the holiday season. And this is not just 2015, it's over the periods up till the, leading up to 2015. And we would introduce a new product about once every 2 to 3 years. So Xbox, you would expect that new version to come out in about 3 years' time. And most often the Xbox would have a life cycle of about 3 to 5 years. In fact, the keyboard that you saw, we still sell pretty much the same keyboard even today, the natural ergonomic keyboard. And before 2015, and again over the period it has been changing and steadily increasing, but before 2015 our COGS would have been in the realm of about 20% of our total revenue. With our launch of Surface products and the multiple entries into HoloLens, which are high cost devices, we have multiple events and markets. So we launch somewhere in the globe multiple times a year, more than 4, and it could be as high. And simultaneously we are seeing the shelf life shrinking. So if we don't release a new Surface, the media is buzzed with, oh, Microsoft is not yet coming out with a new Surface. And that is the changing landscape where the market is expecting a new product to be introduced much faster. And our COGS, these are high cost devices, premium market devices, and our COGS as a result of our total revenue, as a result of COGS has increased up to 35%. With our year over year increase of COGS of 15 to 33% over the last 5-10 years, one of the other things that happens is inventory obsolescence is playing a big role. It's no secret that Microsoft had to take a big write-off a few years ago on our inventories. The increase in these COGS and the inventory obsolescence obviously led to coping mechanisms, which I'll talk about. But before the coping mechanisms, we also had a lot of opportunities. We also wanted to see how we can use the build to order, especially as we are getting into the phones business at that time, but even in general, so we can manage our inventories better. And mass customization, which you saw with the example custom controller that you saw there. The coping mechanisms the organization had built in was, hey, we had to take a huge inventory obsolescence. Whose fault is it? Sales guys, you didn't give me a clear forecast. So you give me a forecast, I'll build exactly to that. And hey, whatever you had forecasted, I'll allocate the product to you. Only if it is within your forecast, you get the product. And we in the TOC community know very well the challenges with pre-allocation based on planning forecast and other things. The negative effects were very, very large. So I have my personal story, which I'll correlate with why some of the changes we had to lead in. In 2014, after I had attended the conference here, my daughter was graduating and Microsoft was having a great event, launching Surface Pro 4. I thought, fantastic idea, I should get that as a gift, the perfect gift for a graduating daughter. So I drove to a Microsoft store and said I would like to have a Surface Pro. Result, no inventory, out of stock. So I'd call once in a while and say, do you have this product in stock? And most of the time the answer, no stock. Now, I being the IT guy with access to data, thought, hey, let me set up a whole report that gives me an alert when the product has arrived at the Bellevue store. So I set up my report using Power BI, of course, and set up alerts and said, okay, I got the product yesterday into the store. So I'd call in today and say, do you have the product? Yeah, they would confirm they received the product. So my report was right. And I'll drive over in the evening, result, no stock. after about 2 months of this, I went in and got a Lenovo Yoga. So that led to thinking about what can be done differently and why is it that this product is. Of course, I was not the only one thinking that way. Microsoft had launched a 1DSC or one devices supply chain principle pretty much to overcome the same kind of missed opportunities. We had lots of manual touches, lots of cost was being incurred in millions of dollars for our recovery, where we had customers not happy with our products, not having the products, and losing revenue here. So one of the things that we did as a company is we placed our bets on trying to minimize the number of satellite applications. I know it's easy to think that, hey, we have all these great applications and for this solution we need another application. But one of the pieces that's eminent in a company the size of Microsoft is if there are too many satellite applications, maintenance and running after them becomes a larger part of the activity than really achieving business value. So one of the strategic themes that we have to say is it has to be SAP, which is our ERP system of record, and we have to use that. We, of course, are major players in the cloud market. We want to use the cloud wherever it's possible. It has to be cloud powered and it has to be agile. One of the tenets we have is enable scale and complexity. What that means is we should be not just producing solutions for today, but they should be able to scale in the future, and we have to enable the complexity that we will envisage in the supply chain in future. I am not going to drain this slide, but our team took a look at the whole supply chain end to end, right from envisioning a product all the way to fulfilling the customer, repairing the units, capturing the feedback, and then optimizing and feedback, and most of it being done with our SAP systems and some of the satellite systems, which is design tools, our supply chain analytics, stores, and our collaboration with our supplier, which is also using SAP's Ariba. So before we jump into what our journey was and what we had seen, let's take a look at the results that we received. Our Chief Technology Officer, Robert Meshew, he could not be here with us today due to prior engagement, but he is here on video sharing his thoughts.
Washington. My name is Robert Meshew. I'm Chief Technology Officer of Microsoft Supply Chain, responsible for everything from how we source product all the way through how we take care of customers if they have any sort of problem, running the technology, the prioritization of all those programs. And I'm faced with a lot of challenges. About a year and a half ago, we were faced with increasing supply chain complexity, rising inventory levels, increased number of markdowns, and a lot of demand variability, especially as we introduce new product categories such as HoloLens or Surface 2-in-1s. So we reached out to Goldratt Labs to really help us think through some of the nuances of the problem. And through that work, we were able to implement a new TOC planning model in our existing execution and supply chain systems. The outcome has been nothing short of remarkable. In that time, we've seen our service levels rise to our customers by a little over 5%. But at the same time, we've seen our inventory levels drop by $250 million across the board, which has led to reduced markdowns and reduced excess and obsolescence of about $100 million. So certainly everyone over here at Microsoft has moved from theory of constraints being just a theory to TOC actually being a reality that has really driven our business to a place that it wasn't before. So with that, I hope you guys all have a great conference, and goodbye from sunny Redmond.
So as Robert had mentioned, we had working capital savings of about $250 million. And one of the things that he did not mention is our inventory turns. We have had our highest inventory turns at Microsoft ever since we have gone live with the business adoption of our solutions here. So we went live with most of the products in September, and we have seen a consistent 17.1 inventory turns in the last 2 quarters. Of course, June's is upcoming, and all this while our service levels were also up by 5%. So in terms of the solution design, I'll walk through the timeline and then we'll walk through the process. How did we achieve this? This is also geared for people who would want to make a change in a larger organization. So one of the things, you must have data. And so I was doing some ad hoc analysis from 2014 after our workshops here, and checking about the impacts, what is our possible solutions, having an Excel simulation so that I can understand the solution and what it can bring. The reason that preparation is necessary is you don't know when the opportunity will come up to present to leadership about some possible solutions. Of course, I was sharing the results with my teammates and others, but it led to a 30-minute conversation with Shane Kolar, who is our senior director of planning at the time, and how TOC could offer a different solution, especially that was geared more towards BTO logic, because we are a 100% outsourced company, not having all the components in our inventory, how we could use some simplified techniques for promising the customer a due date. And that then led to an email from me to Alan and said, hey Alan, are you in town? And of course, just like Alan is somewhere around the globe at any given time, he said, yeah, I'm in the US, I can show up next week. And so 26th, he came by, we had the first workshop. Now, of course, his availability was so fast that we had to go struggle to see how we can make it happen that he can come and present to us. And anyway, August 26th, he came in, had a first workshop with our CTO, and it was more like, hey, you can present, and if we like it, we'll go forward, otherwise it's good attempt. So we had a lot of senior leadership present in that particular meeting. And then from the 28th through the 13th, we worked offline with trying to create a good simulator with the analysis of the current data, so we can make a business case of how it could benefit. And lastly, then September 4th, we went into a technical solution design workshop in the September, about 2-3 days, and with all the resources that we had from SAP expertise, from Illumity, and then other people from Goldratt research, and our own planning and IT teams, all in the workshop together of 3 days, and we had a direction of solution ready. Of course, we are constantly testing the simulation, and we were developing this software in the SAP, the modification that we need to make in SAP during the time between September to December. And we had, on December 16th, we had the first go live of the system changes. There are some special situations for Microsoft. We are a launch business. I know that quite a bit of literature in the TOC ICO talks about how we can avoid launches. Those are opportunities that we would be looking at in the future, but we want to generate that enthusiasm in the market before we launch a product, and so we are still pretty much a launch business. We are a 100% subcontracting model that didn't pose as much challenges in the solution design directly, but it does pose challenges in how we communicate with our suppliers, how we know what the inventory levels are, and especially for components and so on. And also how suppliers continue to purchase based on forecasting. So it was very important that we had to ensure a way of communicating the forecast while implementing our solution. Our product lead times, I had already mentioned that we have product life cycles of 1 to 2 years, but our component lead times are 3 to 4 months. And these are not because sourcing had made any kind of a pricing agreement for a longer lead time. These were genuine lead times because the components are in short supply, or we are a smaller player in the market of who is chasing the components. And last but not the least is our demand peaks. Unlike a normal run business, even during our run phase, we would have peak demands. Now, Xbox, of course, is a classic with respect to the peak demand situation. October to December would be the highest ever, and then it will be a smooth roll throughout. But even in Surface Business and others, you will see that, okay, you have a peak demand here, then it will fall down, then you will have demand, and these are like 2x, 3x, 5x the normal run rate, and we saw that the traditional TOC model did not perfectly give the results that we are hoping for. So I'll let Alan walk you through the solution design elements, and then I'll come back and talk about how we implemented it.
Thank you, Manohar. As Manohar mentioned, my side of the story is around the end of August 2015, I get a call from him after an email, and he said, when can you be in Seattle? And I said, actually, I'm in the US at the moment. I can make it there next week. And I arrive at the airport and make my way through to the beautiful Microsoft campus, and he says to me, good news and bad news. I said, well, what is the good news? He said, we've got a really senior team from Microsoft attending the workshop today. I said, well, that's really great. So the CTO is going to be there, and what's the bad news? He said, well, you have around an hour to convince the CTO that TOC can provide an effective and efficient solution to reduce the shortages as well as surpluses within the Microsoft supply chain, and that it can do it in a way that can provide an end-to-end solution. I said, wow, and if I manage to get through this hour and convince him, he said, well, then it's simple. Then you have the rest of the day to convince his direct reports. I said, wow, and if we are able to do that, he said, well, then the second day we'll plan the implementation. This was incredible, but I had to ask what would happen if I couldn't. And he said, well, then you'd be able to do some sightseeing in Seattle on Microsoft's expense. So it was an incredibly ambitious challenge, and I realized immediately that what I prepared for the meeting was simply not going to work, and that I needed to focus specifically on the difference between concepts or principles that are universal and applications that are very specific. So what I presented to the CTO and the leadership team was an analysis that we had been doing over the last decade or so to differentiate between planning mistakes that are made in managing supply chains, execution mistakes, as well as continuous improvement mistakes. It turns out that there's two key decisions in each of those. There are conceptual mistakes that we make. For example, if we look at planning, how should we allocate resources? And that resources could include stock, it could include capacity, it could include time. How do we actually allocate the resources, including people? The conceptual mistake is that we allocate resources ahead of time based on forecasted demand, and then we end off with too much in one area, too much in another area. And then, of course, if you think about the common example from government of spend it or lose it, what we end up doing is not only we then sit with too much in one area and too little in another area, but with rules like spend it or lose it, we are encouraging people to spend it even if they don't need it, else they will lose it. Something similar can happen also in the supply chain, where when you are launching a product, you have to allocate stock to various customers based on their best forecast. And if you allocate the stock incorrectly, you might get a situation where at the customer level, variances can cancel out. So they order 5,000, they have an allocation of 10,000, you only ship them 5,000. The next week they order 15,000. The allocation rule says you have only 10,000, but you have an unused allocation of 5,000, so we can ship you the full 15,000. So these variances can cancel out at the local level, at the customer level. But what if one customer consistently orders more and another customer consistently orders less? You might have a situation where you have stock building up, being allocated to one customer and have shortages in another. And this was the direction that I presented to the CTO and his leadership team, is to say, we shouldn't be arguing about which is the best application or algorithm to be able to determine where to keep stock, how much stock to keep, how to replenish those stock and how frequently, when to resize the stock and capacity or time buffers, and by how much to resize them. What we should look at is what are the key decisions that have to be made within the supply chain, what are the conceptual mistakes that are made, and what is the rules that we can use to best reduce those conceptual mistakes. Once we have that knowledge, we can then turn it into a specific application that, as Manohar mentioned, would fit exactly the boundary conditions, the types of complexities that they face, the type of variabilities and uncertainties that they face. We started off with this very ambitious target, as Manohar mentioned. We needed to provide a design for best practice TOC-based solution, end-to-end solution for the whole supply chain. We needed to convince all the stakeholders that whatever design we come up with will actually improve substantially the results, will reduce shortages, will reduce surpluses, will provide better and faster responsiveness when there are emergencies in the supply chains. But at the same time, we needed to formulate the rules in such a way that it can be implemented within their standard SIP system. And not only that, but to be implemented within just 3.5 months from starting the design process. So we've used a technique that is commonly used in theory of constraints called a strategy and tactic tree. And we've used that to develop the logic around what the design should look like. So at the top of this tree is that there is a successful implementation of the One DSC initiative at Microsoft, essentially one simple Microsoft for managing supply chains. In order to do that, there's two key components, is to build a competitive edge around supply chain reliability and performance and availability. And a second component, which is building a supply chain that can be incredibly responsive to deal with fluctuations in demand. In order to build a competitive edge around your supply chain performance, the first key requirement was to develop a dynamic simulation model. As Manohar pointed out, we had 2 weeks to do that using actual data from, in their case, their distribution centers and actual customers to see if we implemented the theory of constraints-based rules for sizing buffers, replenishing buffers, as well as resizing buffers, whether we can actually substantially improve on their current level of shortages and surpluses. The design ended up consisting of 6 parts. The first part was to decide what should be the rule for deciding on the order fulfillment strategy. As Manohar pointed out, there was a key urgency around implementing build to order by December, but a number of other order fulfillment strategies also had to be implemented inside of SAP. We also had to implement assembly to order or bundle to order. We also have to implement build to availability, which is the equivalent of building to stock, but with a guaranteed availability to the market. And then 2 others, which was a BTX or build to X, where X represents a target quantity for the launch of a new product. And lastly, CTO, which is complete customization to order if you have a product that can be ordered with many different configurations. So we developed a rule for deciding what should be the best order fulfillment strategy per product channel market. The next thing we did was to say for those order fulfillment strategies where we will use time buffers, in the case of assemble to order and build to order, we needed a mechanism that could reliably predict what the actual delivery lead times would likely be if you were making commitments. And of course, the common mistake, the generic mistake that we make there is that we ignore the backlog. You can't keep on quoting 2 weeks if you're already sitting with 3 or 4 weeks in backlog. So we developed a very simple rule that considers the backlog when it makes reliable commitments to ensure that we provide safe due dates for both build to order as well as assembly to order. On the items that we've decided to keep stock of to guarantee availability, those are called build to availability or bake to availability. We defined what the typical planning rule would be for sizing stock buffers, which is how frequently do we place orders? Is it daily, weekly? That gives me my demand or order lead time. Then what is a reliable estimate of my supply lead time? When I add those two together, I get my total reliable replenishment time. And from that, I then need to know what is the maximum demand that I expect to have within that reliable lead time. And I can look backwards and forwards, and that would be my starting stock on hand. I then replenish, because theory of constraints is based on the reorder frequency basis. I then replenish based on the frequency that I selected, whether that to be daily, 3 times a week, once every 2 weeks, or once a month. The more frequent, the better. And I replenish based on that up to the target stock level that I've calculated. And then the third rule that we had to decide on is when do we resize the buffer? And there's a traditional theory of constraints rule that look backwards at too much red. Red is the bottom third of the target stock level, which is red indicating a near miss of having dangerously low stocks. If there's too much red, we have a simple rule that says increase the target stock level by 1 zone. At the same time, if the stock on hand doesn't come out of the green zone, which is the top third, we then have a rule that says too much green, we can safely reduce the target stock level without any danger. And that was the third rule that was put in place to answer the question, how much stock to keep at any point in time. The next rule that we had to develop was how do we control the release of work when you have such a hybrid of order fulfillment strategies? Because you, on the one side, do not want to overload the factories that will cause their lead times to start growing exponentially, putting you into that chaotic zone where lead times are growing and throughput is dropping and reliability is dropping. At the same time, you cannot afford to underutilize them too much because then you are essentially paying for capacity that's not required. So how, with all these different order fulfillment strategies, can we control the release of work to the various contract manufacturers to keep them busy enough, but not too busy? And that rule was designed. The fifth one was a rule for how do we maintain a single priority system. You will notice in theory of constraints that we use colors to determine priorities. So black is always more important than red, then yellow, then green, and then blue is the least important. If I'm managing stock buffers, then black means I have a stock out with demand. Gray would mean I have a stock out without demand. Red means it's a near miss. Yellow is around the middle section, and then green is at the top. And if for whatever reason, maybe a minimum order quantity, I've decided to buy more stock or produce more stock than what my target stock level requires, it will then go into a blue. And I can, of course, quantify the percentage of black and red and blue to give me an idea of how good my supply chain is, how effective and efficient my supply chain is. And if I put dollar values, I can see how much sales I'm putting at risk by being in the black or the red, and at the same time, how much working capital I'm carrying that is not necessary, which is the dollar value of the blue inventory. And then the final one is developing a mechanism that's continuously identifying not just the percentage black, red, and blue, but also what's causing those black, reds, and blues. So that can drive, after Pareto analysis, that can drive our continuous improvement events. So those were the 6 rules that we designed. The strategy and tactic tree was used to clearly define what the objective of each of those changes were, exactly how the rule will work, and what are all the assumptions that we've made about why this change in rules are needed and why the tactic that we've selected is the best way of doing it. And in the tactic side, we then took responsibility for producing graphical pictures of how that rule should work. This was presented to the SAP teams in rapid prototyping workshops so that they can fully understand exactly how the rule would work. They were given the opportunity to ask any questions that they might have, if there was confusion exactly how the rule will work or could work in special circumstances. And then finally, they would come back with a design in SAP. We have done a number of implementations of TOC in SAP, so our team from Goldratt Research Labs and Illumity could offer some advice about what is the simplest possible way of implementing these theory of constraints rules within standard SAP. I'm now going to hand back to Manohar to share with you some of the lessons that we've learned, and we'll also cover some of the innovations that we've had to make in terms of specifically 2 different order fulfillment strategies. The one is a hybrid that is not just looking back at too much red and too much green, but also is looking forward and trying to differentiate between noise in the forecast and signal. Signal would mean there's an end of life event, or on the other hand, there's a big predictable spike due to some special promotion or maybe a holiday event. And we have to consider those into the building of stock. So you'll cover that. And then the second one was a build to X rule of how do we decide when to start building stock if we are given a launch date and a launch quantity. So I'll hand over to Manohar now.
Yeah, thanks, Alan. So our learning, of course, was that the build to availability or the make to availability we could not apply in all the situations. One of the main ones being when we are launching product. So in the launching product, in many cases, we have very less consumption history, and this could even be driven by an S&OP decision of, okay, I want to launch this many units in this country. It could also be a holiday scenario where we have a limitation on how many components we could gather, or a financial limitation on how much working capital we are going to put in into those areas. And so those are the ones that we called it as BTX, where it is primarily driven by higher level approvals of the total quantities, individual SKU mix still being left to in decisions, and then it would adopt a push supply model where we don't have enough signals yet to react to the market. Then during our sustain phase, which is we would choose with different factors, whether, hey, what is the cost of the product, how much is the customer tolerance time, and so on, between one of 2 models. One is to say we'll build it to stock and with guaranteed availability, thereby able to service the customers with short lead time faster and having the buffers at the DTV. This would be a pull supply model. And then of course the other classic one is the building to order, where we would have the customers place the orders and then our manufacturer would make it and send it across. That does mean that of course we are carrying component inventory at the factories to cater for the unexpected demand as we get through. Finally, towards the end of life, and we are rethinking this at this time, because end of life, when we approached it, we thought, okay, we can always do it as a BTX. In many cases, that's true, especially when we are decided to say, okay, we need to stop this product even if it is selling well, because we are launching a new product and that life cycle is coming across. That's one possibility. The other one that we are debating is whether or not we should use ATO to check whether if the demand is slowing down and we want to continue to play in the market, then can we continue with the ATO model in that and check that. We are not yet completely solidified on those, but for the most part it is leaning towards a combination of the 2 depending on our product and the life cycle. As you can imagine, the life cycles as well as the demand patterns of our different lines are very different. Our Xbox does not have the same demand pattern as our Surface, which doesn't have the same demand pattern as PC hardware. How many times do you get excited that, oh, I'm going to buy a new mouse for my son this holiday season? Less likely. So one thing that we did find because of our, even during the sustain phase, where a normal traditional TOC implementation should have worked, as I pointed out before, our peaks and valleys could be pretty high. And as a result, we found with the simulator that Goldratt Research has built that traditional TOC may result in stockouts. Now, it is still better than what we were operating at, but we said that that's not good enough. So working with Alan, came up with the hybrid TOC model where we could distinguish the forecast as a noise versus the forecast as a signal. And what we did was setting the initial target, just like we recommend, is we look at the peak demand within a RRLT. Of course, there are multiple other ways to do it, but this was the way we chose based on the recommendation from Alan to say pick the peak demand within a RRLT or slide forward for the period that you want to see. So for example, if my lead time is just 4 weeks, I may not want to consider just the 4 weeks demand, and I may want to look into the 4-week period for the next 6 weeks in. So we will pick one of those, pick the 900 and set that as the target stock level, which includes on order and on hand inventories. And it use the standard method of 33% each to say red, yellow, green, a third of the buffer. And then just like in a traditional TOC, would replenish whenever the sale has happened. Would look for when we are recalculating the cycle of what the dynamic buffer should be, would look at the same traditional two pieces. Too much red, that means could we have stocked out? If so, we will increase the target. And too much green, that means have we been carrying too much? And if so, we would try to reduce the target. The piece that we added in was a third, which is repeat of step 1. We would check again whether the forecast in the period is actually substantially higher or substantially lower than what our TMR, TMG or our current target stock level is. And here again we have used a simple rule of 1/3 for now, and we will be evaluating when it makes sense to change or even eliminate, and set the target based on the revised forecast if it is substantially higher. For example, if my TMR, TMG calculation or my current TSL was at 1200 and the upcoming forecast it said that the peak is 1800, we would choose 1800 as our target stock level. But if it just gave 1500, we would say, yep, it is within the noise range, and we could ignore the forecast and react to the market because there is inherent variability anyway. So that was the piece that was added in. And how we would do this is we would analyze the patterns for each of our different product lines, simulate the rules, then implement it in SAP. Every one of those factors there is a parameter in SAP that we can tweak by product line or even down to the SKU level. For example, we are finding some cases now, and I got a team reviewing this right now. We have found some cases where the forecast, although we said 33% high or 33% low, is more likely a signal than a noise. We actually found that in some cases that's not true, that even at those levels of variation it is a noise. And if that is the case, then we are looking at does it make sense to turn off looking at the forecast or vice versa. And with that, I'll hand it back to Alan to walk through and give a demo of the simulation model. Alan.
Thank you, Manwar. Building the simulation model was one of the key changes that I think was a major key for success for this project. The simulation model was essentially used for 3 purposes. The first one was to answer the very simple question about is it possible to do significantly better, not just in terms of operational performance, but also in financial performance. We built 2 versions of the model. The first one was a relatively simple model that just looked at the stock holding at the DCs and took customer orders. The second model we built was a model that is completely self-configurable from data that can typically be read in via an export or a query run out of an ERP system like SAP. So if you look on the slide, we have data that we are reading in that are coming directly from SAP through SQL into an Excel template that we've created. And this data describes the full supply chain. So depending on what you want to model, you can model as simple a supply chain as a single factory making one product being sold directly to one customer. Or for each of those, you can add additional rows, and you could have multiple factories making multiple products being sold via distribution centers to multiple customers. You can even include bill of materials and then also bring in tier 2 suppliers on top of all the description of what the supply chain looks like and the various links between the nodes in the supply chain, the mode of transportation that is used, what products can go where on what mode of transportation and the costs related to that transportation. We also read in the actual lead times that are sitting in item masters that are being used for quoting. We are also reading in production capacities for the contract manufacturers. How many lines did I have? What's the production capacity per line? How much setup time is lost when you switch from one product to another product? And then lastly, we read in the demand, both the forecasted demand of what the forecasts were at that time, as well as the actual customer orders that were coming in. This information then goes into the model, and on top of that, we engage with the experts to add randomness. So there might be a parameter in SAP that says the lead time to produce one of these items is 7 days. And what we can ask the expert is, tell me what is the minimum it's ever taken, and tell me what is the maximum it's ever taken. And from that, with maybe a simple triangular distribution, we can then bring randomness into the model. We want to be able to press the play button and see if by following the new TOC rules, we could have done better than what had happened in the past. So the data that was read in about the actual stock level by SKU, by location for every day over maybe the last 12 months was used as the baseline. We will use the simulation model to model every single event in that supply chain over that period of time, but now reacting according to the TOC rules that are completely automated in the model to see if we could have achieved lower levels of shortages and surpluses and faster responsiveness when there are critical events like unplanned downtime. Once we have the data in the model and the model self-configures, we can then run the model. There's a number of ways that we can run the model. We can run it as a single run. So you decide on your parameters. Before the run, you press the play button. And it takes about 10 seconds to model every single event in the supply chain over a year period. And you can then see the outputs. But you can also run the model as a sensitivity analysis. So we can select one of the parameters in our rule and ask the question, how sensitive is the performance to this parameter? If we decide to look ahead, for example, 3 reliable replenishment times. Our reliable replenishment time is maybe 4 weeks. So I want to look ahead 12 weeks. I think 12 weeks kind of makes sense. We can run a sensitivity analysis to say, does the operational and financial performance change at all if we look forward only 1 week or 2 weeks or 3 weeks, all the way up to maybe 26 weeks? And we can see how the graphs for both the operational and financial performance changes over that time. The last way that we can run it is scenario comparisons. We can create scenarios with a specific rule, run it, and without that rule, and run it and compare. This was extremely useful when it came to understanding the consequences of allocations, as I previously mentioned. So we ran a scenario that was enabling allocations, so it essentially was enforcing this allocation. So if you have one customer that's continuously under ordering, but another one continuously over ordering, it could result in stocks building up while at the same time you potentially are losing sales, compared to running that same scenario with the same random seed, but just not following that rule. Essentially producing only what customers are really ordering and checking if we can in that way better fulfill their demand from that scarce supply of product at the product launch typically. The outputs are produced in a number of different areas. There's inside of the model itself, you can see graphs and statistics while the models are running. You can see entities moving. You can see trains and trucks and ships moving and products moving. But you can also get Excel reports and then logs where every single event is logged. When you open up the model, it gives you an opportunity to upload a data file, and that data file then will determine how complex the model is. So if you imagine just if there's a single product, it has a single row. If there's 10,000 products, there will be 10,000 products 10,000 rows, our model will keep reading until it gets to the end of the record, and that's the configuration that will be used inside of the model. The user interface was purposefully kept extremely simple. They simply open up an Excel file. Once they've done that, the Excel file then reads in, and the model then gives a summary of what data we have read in. In the top left-hand corner, we can see information about the time period for which we've received actual stock on hand, actual customer orders, and actual forecast data. We can also see which portions of the supply chain we've read in. In this case, there was 1 tier 2 supplier, 5 contract manufacturers, 11 distribution centers, and just under 2,000 tier 1 customers. We can also see the product categories, the average and daily maximum demand for each of those, and the production capacity to spot if there are obvious bottlenecks. We also have added functionality that allows us to either read both the demand forecast as well as actual customer orders from the Excel file, or, as Manohar mentioned, we can use this as a product launch simulator. So we can read and forecast and then generate actual orders with a forecast error to see how the supply chain will cope with that. If the supply chain is harmed more by a negative forecast error than what it benefits from a positive forecast error, then by definition the supply chain is fragile. It will be harmed by volatility. So if we make 20% more, if we can sell 20% more, but we lose 30 or 40% if we sell 20% less, we know we have a fragile supply chain. If we find out that by selling 20% more, 20% less, there's an equal profit and loss associated to that, the supply chain is quite robust. What we wanted to do is to see, can we come up with rules that will create an anti-fragile supply chain? One that limits the pain during a downturn, or where you are selling less than what you forecasted, but at the same time can fully capitalize on the situation when the demand does exceed the supply. So this section of the model allows us to create forecast error, see how the supply chain responds. We can create only a positive error, or only a negative error, or a random error to see what the response is. We then have a section where the users can select which rules they want to use for that run. Do they want to dynamically resize stock and time buffers? Do they want to dynamically quote different lead times based on the backlog? Do they want to enable or disable the allocation rule? And do they want to use the traditional TOC rule for dynamically resizing buffers based on too much red, too much green? Or do they want to use the new hybrid rule that also pays attention to forecast? And then the last section is, this is where you can select the type of run that you want to do. Do you want to do a single experiment run, sensitivity analysis on any of the parameters, or a scenario comparison? You might be wondering, how did we achieve this very fast implementation in SAP while we were still testing whether these rules will really get the expected results? What we did was we identified the structure of the rule that are very generic and parameterized that rule. So the structure of the rule was implemented in SAP, keeping the parameters as variables that can be modified by the supply chain planners. And we used the simulation model to identify what those parameters should be. As Manohar said, we were surprised, pleasantly surprised, to see how robust the standard default settings are that we are using within theory of constraints in our standard rules. But there were cases, as he mentioned, like the Xbox, where the standard parameters didn't perform well, and we could do sensitivity analysis to see if we can fix the problem just by changing the parameters, or in the case of a hybrid rule, that we actually had to create a completely new rule. When you click on map, it quickly shows the user what the supply chain looks like that was read in. And we can also look at cumulative flow diagrams to quickly see the cumulative capacity that we have available compared to the cumulative forecast that was read in, and the cumulative actual orders and stock allocations. In this case, we can see that the demand forecast for this specific category of product was actually below the actual orders that were received for this period, which could explain why there were shortages if you were using rules that were driven by forecast. That, of course, wouldn't happen if we were using the TOC rules, the traditional TOC rules that do not look at forecast in deciding by how much to resize the buffers and how much to place. The final side is when you've run the model, and I'll do a quick live demonstration now so you can see it in action, is to get an output. And the main two graphs that you see on the screen at the moment, the purple lines are indicating what the actual stock levels were during that time period on the left-hand side. On the right-hand side, it shows what the level of sales are that was put at risk during that time period due to shortages. And the blue line is showing what the stock levels would have been with the TOC rules. In this case, you can see during major parts of the year, the TOC stock levels were predicting to have almost half the stock than normal. And it showed that it would have been possible to reduce the stock while at the same time almost eliminating completely unsatisfied demand. You can also zoom in to a specific distribution center, and these colors are representing each product within that distribution center. The bottom charts with the colors are showing what the actual stock levels were and the percentage of time it's spent in the various buffers. So you can see a lot of blues there, which means that you were carrying too much stock, but you can also see some blacks, which means that you were, at the same time as carrying a lot of stock in some areas, you were stocking out in others. The chart on the top side is showing you what the buffer stock levels would have looked like if you were using the standard TOC rules. And you can see there are some items that have significant reds, but almost no blacks, and quite few blues. And then lastly, you can zoom into a specific item in that distribution center and again see the purple line representing the actual stock on hand that was happening, and the blue lines presenting the stock on hand that would have been if we had been using the TOC rule in fully automatic mode. So I'll quickly switch over to the live demonstration now. One of the reasons why we use the AnyLogic software simulation platform is that it does allow us to model in AnyLogic. Literally, we can use discrete event, agent-based, as well as system dynamics. And the second thing is that we can export the model as a Java application that any user can run on their computers without needing expensive simulation licenses. So as we mentioned, the user will click on load, and it reads one of the files containing the data of the simulation runs that they want to run. As soon as they've loaded up, they can click on a map to see what the supply chain looks like that they've looked at in this case. They can even click on one of the units, in this case a contract manufacturer, and see some basic information. In this case, we can see that we have 2 production lines running at this contract manufacturer. We will come back to that later to show how the simulation can also ask ongoing questions that will come up in sales and operations planning about whether we have too little or too much capacity or stocks. I can look at the time period for which I've read in the data, the products, and the nature of the supply chain, and as we mentioned, various parameters that I can set. When we click on run, what the simulation is going to be doing is it's going to be replicating every single event that is taking place in the supply chain over this time period. I have to slow it down because it only takes about 10 seconds to simulate every single event over a year period. If I go into the contract manufacturer here, we can see how the orders in the top right-hand corner are coming through from customers to the distribution centers. Those orders are automatically color-coded. The orders with due dates are assembly to order and build to order, and the orders without due dates are building to X or make or build to availability. On the top left-hand side, we can see how we are calculating what the backlog is or the planned load on this factory. And we want to monitor whether that backlog is growing more than about half our time buffer that we are using to control the release of work in process into the supply chain. Once it starts exceeding half of our time buffer, we have to start increasing our quoted lead times. And what we can see at the bottom left-hand side here is that, yes, there was an increase in the planned load up to about 20 days, but the supply chain quickly recovered, and after that, the load on the factory at any point in time was not significantly more than 1 or 2 days. And we can see the performance of the build to availability and build to order. Initially, there was some capacity issues that caused some blacks, but after that, it's mostly green. Switching back to a specific distribution center and going into a specific item in that distribution center, I'll speed it up so we can see what it looks like until the end. And remembering that the purple is indicating what the actual stock on hand was for this item over this time period, which ranged from December 2014 to September 2015, which is when we started the project. You can see that there was significantly high stocks at the beginning. The stocks probably sold much faster than what was expected, or there might have been delays in the supply chain. Regardless, there were 2 major stock outs that was happening. Then stock suddenly came in, and they were left with a lot of stock for many months until they stocked out again. And what we can see is what the theory of constraints rules would have achieved in stock holding in fully automatic mode. And this was an important criteria for the project. We wanted these rules to work essentially touch-free. The supply chain planners, like any of the managers in organizations, there's always more things that demand their attention than what they have available attention. Attention is the chief bottleneck in management. And by automating these rules, we're allowing them to focus more on the things that they are uniquely qualified, looking at which orders to expedite, working closely with suppliers and customers, finding out why we still have blacks or reds or blues, and working on those continuous improvement while providing oversight on the rules themselves. And as you can see how the target stock levels here are being updated, we started off with the green zone at the top. The stock on hand stayed in the green zone for quite some time, long enough for the rule to say there's too much stock, you can safely reduce the target stock level. We wait until the on hand gets back into the green before we start monitoring again, else we could trigger a vicious cycle. We stayed in the green again for too long, we reduced the stock, and then quickly the stock dropped into the red. We realized that it was too far and we adjusted it. And over this time period, the rule ensured, and this is the standard TOC rule, ensured that we achieve much lower levels of inventory, much lower surpluses. At the same time, we've achieved no stockouts. Overall, what the simulation showed in this case, the blue line is the inventory with TOC, the red line was the inventory as it was using the traditional rules, substantial reduction in predicted by the models in terms of overall inventories, which was backed up by the real results that were achieved initially at the proof of concept pilots and later with a full rollout, as the CTO mentioned, seeing reductions in inventories of around $250 million over the period, while at the same time improving service levels from the low 90s to the high 90s by about 5%, and at the same time also ensuring that we are achieving larger sales volumes, over 100 million in additional sales, by preventing markdowns or the problems that was experienced with allocations or stockouts that could have been prevented. So that's the story for the way that the simulations are run in the way of answering the question, can we do better? Of course, the way that the simulation is configured, it can also be operationalized. So we can upload the data of the supply chain as it stands right now and ask what-if questions. If you remember the graphs that we saw looking at the factory, the factory initially it was utilized to 100%, but after that it was utilized less than 50%. And we might ask a question looking at this factory utilization that's sitting on average below 50%. Could we have done with only one production line? So we can go back, we can change the production capacity to just one production line and rerun the model using exactly the same random seed of data. Again, go back into the factory, and immediately what we see is a tremendous amount of blacks. There's backlogs building up in the factory, and those backlogs weren't recovered within a month. They took almost 6 months to recover, and during that period, all the build to orders items would have been late if we had not increased our quoted lead times on them, and we would have had significant stock outs on the build to availability side. So that's the way that this model can be operationalized as a key decision support tool within the sales and operations planning, for example, as well as a tool that can be used for product launch simulations to see what will happen if we significantly exceed our forecast in terms of actual sales, or that the actual sales are significantly below our forecast. It also provides us a tool to stop arguing about whose rule is the best, but simply to create a rule in the simulation model, run a scenario comparison, and see which rules perform the best, because the rules, as I mentioned before, are specific applications. Any applications always have boundary conditions within which they work well, and boundary conditions outside of which they might not work well. So we can use the simulation model to check how much better could we have done if we had changed the rules, but also which rule is the best to match our starting conditions. So I'll hand back to Manohar now to end off the presentation with a discussion around the implementation itself, some of the more technical aspects, as well as a project status update, and then some final closing remarks.
Thanks, Alan. As you could see from Alan's simulation, that simulation model was crucial for us to check the rules, get the buy-ins that are needed. We're not yet operationalized it in the sense of running it on a frequent basis. We have started that initiative now to go back and reevaluate the rules that we had used and see how well they are working, other than the results that they were giving, whether we can tweak them or other boundary conditions have come up. So in terms of implementation, for those of you who are interested to see which parts of SAP we would have implemented it in, we use both the APO and of course the standard ERP of the SAP side. So we calculate the target stock level based on capturing the lowest inventory. Now this piece is key. It is important to say that we are not taking just the snapshot of inventory at the end of the day. We are taking whether we could have stocked out. So that was something that we had to introduce in to capture the lowest inventory levels. And then of course the lead time and calculate the target stock level based on the rules that you mentioned. Because we have in the hybrid forecast, we also get the forecast, a hybrid TOC model, we also get the historical forecast, which is more called statistical forecast or consensus, arrive at which one we'd use, and that forecast is also fed in for the calculation of the target stock level. Now the top of the green is essentially set as the reorder point, whereby every time that the inventory plus on hand plus on order falls below that, system will automatically recommend buying from the supplier. And then that then gets converted to a purchase requisition, and then those purchase requisition get converted to a purchase order, which are then communicated to our suppliers. We use SAP Ariba for our supplier collaboration, where we transmit the data over, we get the confirmation back from the suppliers, and they say whether they can or not meet it. Now that portion of the work will be further expanded as we go into the next technologies of IBP. The BTO implementation in SAP is we were able to leverage quite a few pieces of SAP logic that's already in there. For example, SAP would use the customer's requested delivery date, subtract the transportation lead time, arrive at a GI, subtract the pick, pack, and ship lead time, and arrive at a MAT date. It could also take a bunch of inventory availability, like you can say these are the inventories that I need to check for, and based on their material availability date, it could forward calculate and say this is when the requested delivery date would be. Now, as I had mentioned before, we may or may not own the inventory that is critical for us to do the checks for, and as a result, it may not exist in our SAP system at all. If it is a component that my supplier is responsible for buying, but we have to check for its availability because it's still a critical component, we had to enable some special data feeds from our suppliers to give us those components or all component inventory such that it shows on our book as not our inventory, because it's actually supplier's inventory, but we use it only for the check. The last piece, which is in the dotted line, is the TOC specific calculation that we introduced, where we would look at and say what is the current load, add half of the production buffer, and arrive at the MAD date. So we were able to combine this check along with the previous two checks of the MAD, and then SAP would automatically calculate a requested delivery date out of it. So that was the change that we had to make in SAP to give us the BTO date just based on the current load and the production buffers. So let's talk about implementation and adoption of the solution and how far we are right now and where we are going. As you had seen, the system did go live in December, and then we ran a pilot from January to March. The pilot runs were for both ATO primarily, which was also built to order, and then for the BTA for a few product lines like the PC hardware and others to see how would it work. The results were pretty nice. We did identify and fix a few bugs, of course, during that period, but overall the results were satisfactory. And then we said we want to roll it out to the larger organization. Challenge that we didn't see forthcoming was, it's not just important for you to get the people who you think are impacted along the change journey, which of course we did with all the planners and the community, but there are others who may feel impacted by the change, and that's important for us to note and have that preparatory work. We didn't quite have that under our belt, so April to July we spent quite some time actually with the teams who perceived that they could be impacted, and then define the rules and operating procedures for them depending on if there was a change or if there wasn't a change in the system. And then finally by the end of August we had mostly implemented for the finished goods where we can, and I say that with a clause because as you had noticed there are different product models, product lines, and for each product line we had a kind of a different boundary condition. So we have implemented on the Surface line of products, the PC hardware business. Custom controllers of course could not work without the logic that we have. Xbox family we have implemented partially, and that's not because of the simulation limitations, but more because in APO, in the subcontracting scenario, we have not yet figured out how to do the capacity leveling and others, and even if we did, we were on the path to implementing IBP, so we are looking at moving that over once we move to IBP. And HoloLens and Surface Hub, at this time we have not moved into the implementation with the TOC rules, more because of the business strategy of what we are doing with those products and how we are going forward. So in summary, what are the lessons learned? First off, to get buy-in, data, very helpful. Not that people will buy the data the moment you present the data. No, that's not how the buy-in works. The buy-in works more to say you know the data, and as a result, you are able to confront the questions that people throw at you. And that's how I would approach the data from a change management perspective. If you show the simulation model and all the complex graphs, people are out already. But you need to have that information so that you can peel in the information that is required to get the buy-in that is needed. Then self-configuration model is absolutely possible even for such a complex supply chain, although it was not easy to create. The number of hours, I don't even know how long each of the teams has spent. A lot of hours were spent both by Alan's team and even me to gather the data, me and my team, to gather the data and produce it such that the simulation model can be used. what we would think is simplest activity, getting a daily inventory balance, can get extremely complex sometimes. So it's not easy, but it's very much feasible. And then simulation tools though are very effective in decision making, especially when you have varied boundary conditions across product lines and so on. And as we said, that also helped us identify any gaps about, hey, would this rule work, or more importantly, what new rule should be introduced. I've already mentioned about not underestimating the effort of change management. And during the buy-in session, the theory of constraints can become a challenge unless it is explained well. And I think Alan had done a fantastic job of explaining. I'll ask him to add in here again about the theory of constraints, how to overcome that challenge.
Thank you, Manohar. During one of the training sessions, we had one of the people in the audience say, so why is it called theory of constraints? You know, we need things that are practical here at Microsoft. And I reminded him of a brilliant quote by Kurt Lewin, who was one of the top psychologists, who said that there's nothing more practical than a good theory. Why is that? Because a theory in science is just a good explanation about why something is important and very useful. So when we talk about theory of constraints, we are asking the question, so why is a constraint really important and why is it useful? And it's useful because it helps us to make 5 types of decisions that are extremely difficult to make in environments that are dominated by VUCA, volatility, uncertainty, complexity, constraints, and ambiguity. It helps us to set ambitious but realistic targets if we knew the potential of the constraint in the system. It helps us to decide what the impact of changes are. Knowing the impact on the constraint is a good approximation for the impact it will have on the whole system. It helps us to decide where to focus our scarcest resource, which is our limited attention. It also helps us to judge what rules most likely will provide us with global optimization rather than local or short-term optimization. It turns out that those rules that help us to better exploit and elevate a system constraint are also the rules that will most benefit the system as a whole. And lastly, the 5th decision it helps us to make is when to change the rules. If a constraint moves, you have to change the rules. And that's why the design of these end-to-end supply chain solutions have to be done in a way where we can keep the constraint in the market, where we never overcommit, where we are more and more learning how to produce what has been bought, not just produce what has been sold, but produce what has been bought, rather than selling what has been produced and then having to make unnecessary discounts. So I'll hand back to Manohar to just say a few words about some of the assumptions that has been challenged. I've already mentioned that in terms of SAP. Normally there's an assumption that it's extremely high cost to do implementations in SAP of any new rules, or that it will take tremendously long time. We were able to challenge both of those assumptions and show it was possible to do it in a very fast time at a very low cost. Manohar.
And as Alan mentioned, last one, SAP is more flexible than it's normally given credit for. We found that true both in terms of the software itself, where we could tweak it with some smaller tweaks in to adjust to what it is required to implement TOC, and also as a company, we were able to get the SAP consultants online, and as we work with them and to say, okay, this is the boundary condition where it's not working, and we continuously have meetings with them to ensure. So I would say that don't think that it is very difficult to implement in an ERP system. It is possible and it can be done. And of course, where we have to go, quite a lot of journey ahead to cover. As I had mentioned, we have done some implementations or adaptations into our finished goods. We need to expand that into our component purchases, and where we are seeing some opportunity. We are also expanding that into our exchange and B SKUs, where we keep the stock for anticipated repairs, and how do we keep the right quantities in stock without having to carry 15-16 weeks of inventory in. Our biggest challenge right now has been systemically communicating build priority with our suppliers. We are able to calculate the red, yellow, green priorities and all, but not systemically able to communicate for the massive amount of SKUs through the current systems that we have. So we are working with SAP and Ariba to say how can we systemically communicate. Today it is offline, done with the planners. And in closing, I'd like to leave you all with a closing thought. This was shared by at least the first time I came across was in a Stephen Covey presentation at Realizations Conference in 2006, I believe, or 2008 possibly, where he mentioned that for steering a large ship, what is required is not the engine, not the red rotor, but actually a small item called a trim tab. And that is coming from Buckminster Fuller, his comment, who was a business architect and a thought leader, and who said that what one little man could do, the whole ship goes by, and then comes the rudder, and there is a tiny thing at the edge of the rudder called a trim tab. I'd leave you all with the thought, be a trim tab. To change large organizations, you need not always be the top guy to come up with the idea. You could make a change as long as you think of yourself as a trim tab. Thank you.
And I think it's a great point to close off the implementation, is that this was an excellent example of how things can be done bottom up. We got approval from the senior executive team to say that this is what we are planning to do. We used the models to predict what the likely impact was going to be. We implemented it within the existing SAP system, ran proof of concept pilots to learn very fast what was working, what wasn't working, and then only rolled it out once we were absolutely convinced that the results were there. So what we'd like to do is to encourage you to contact us if you have any further questions, or if you come up with new rules that you think could outperform the rules that we had described, you're welcome to send us emails, and we can build those rules into our simulation models and test what the results would be. So thank you very much for your kind attention, and we look forward to being back potentially next year to give an update on the results, the further results that have been achieved. Thank you.